So I guess to start with, my name is Brandon Miner. I'm the CEO of Tangram Vision, originally Tangram Robotics, believe it in fact, and we'll kind of go into that later in the presentation. With me today is Julie doing the administrative side of this whole webinar. Thank you, Julie, for putting this together. We will be, this presentation webinar is organized about 30 minutes of me talking about how we utilize Rust for robotics and computer vision here at Tangram. And then at the end of the webinar, hopefully I will have given enough time for us to have kind of a back and forth in the question and answer feature of Zoom to answer some of your questions about getting Rust into production, or how we've tried and failed to do something, or what you're looking to do in the ecosystem, or just what Tangram's about. All these questions and more. So let's get started. Tangram Vision, as you might know, we are a company all about making perception easier to use from beginning to end. So our core competency as a company is actually calibration. We see calibration as the core of computer vision and perception. If you get that right, everything else just kind of flows. Our backgrounds, the entire team actually, are in autonomous vehicles, sensor manufacturing, calibration, SLAM, pipelines, monocular, stereo, whatever, depth, inference, sensor fusion. We've kind of done it all as a team, which means we've felt all of the pains as well. And key to those pains throughout all of our careers is the ecosystem, programming, trying to get all of your tools to work together as one. So back when Tangram Vision was Tangram Robotics, one of the earliest things we decided as a company was to adopt Rust as our programming language of choice. So why Rust, you might ask? We are all of us familiar with C++, Python. We had used esoteric language, esoteric. One of our engineers would get very mad at me. Jeremy would not like this. Scheme, Pascal, functional programming, object-oriented programming. We kind of gone through it all, and we understood very well the drawbacks and advantages each of those things had. When we jumped into Rust, none of us had used it at all. We really just came for the promises it made, and we are happy to say that it kept those promises to the T. And mainly for us, we adopted Rust. Why was Go rejected? We'll get, I can cover that at the end. Rust only right now. We went into Rust because hardware is hard. So what I mean by that is hardware is not just, the interaction between the physical and the digital. It is that plus communications and firmware, that plus the API to move your data, that plus the user interface for your software, that plus, the API that you need to process all of this given multiple hardware items. So when we looked through our careers and said, what is the hardest thing we ever had to do? It was interacting with and pulling out hardware and the data that came with it. When we looked at Rust, we were like, what can it do to mitigate the hardest problem working with the hardware? And there's a lot. The very first thing is safety. So I'm going to be honest, I'm probably preaching to the choir here, but it's worth reiterating because, again, when we adopted Rust at Tangram Robotics, now Tangram Vision, none of us had ever programmed in it before. We had never used the ecosystem. So these were all just promises we thought it could keep. Safety is very first and foremost. Hardware is hard. Rust doesn't make hardware easier, but it makes the dangers known. And this is 90% of the problem with the ecosystem at large in any other languages. When you program something in hardware, it may take you a day, a week, a month to figure out exactly where something is going wrong. Rust eliminates that choice. You can program something wrong, but as soon as you do, Rust tells you. And unless you go into unsafe modes, which you have to do consciously, and you have to know your memory is not going where it needs to be, Rust will always tell you you're wrong. Just that alone was such a valuable piece of the language for us. Even better, it has a strong async ecosystem. And by this, I mean parallel processes, multi-threading processes. If you do that wrong, it will also yell at you. And Rust makes it very hard to pass memory along multi-processing pipelines in a willy-nilly fashion. And we'll kind of go into one of the products Tangram's built that showcases our excitement for async later on. And Rust is also compatible with C for those hard to reach areas. So if you need a program in C, if you need to go really low level and it's just not, your purview is not quite there for Rust, you're allowed. So all these things combined, that alone made Rust desirable for us as a company, and we adopted it right away. But as we got into it, we found some other benefits, mainly performance and tooling. Rust was fast. When we adopted it, compile times were a common gripe in the ecosystem, but to be honest, we've never had issues with compile times, and we make some pretty dense code. It also has native cross-platform support. So if we built on our Linux machines, and everybody at Tangram uses Linux, we don't have to necessarily tailor our code to a certain platform. This has also become easier because the ecosystem has, narrowed down the, x86, architectures and such like that, where you don't really have to worry about more esoteric platforms. But that being said, it's still true. We don't have to cross compile. It just kind of happens. Cargo and Clippy are also the best, easy to use tools we've ever had. We don't have to put in, linters or tests. It's just there. Also, I'm kind of going through these priorities as, I think, not necessarily from most important to least, but we adopted it for safety first, and then we found performance was great. And now expressiveness was another big benefit. So like I mentioned before, we're not just familiar with object-oriented programming, the team is also familiar with functional programming, and in some cases has stronger programming paradigms in functional than we do in object-oriented. The good thing about Rust is that you don't need to necessarily, choose one or the other. You're not in either land. There's a lot of functional programming in Rust natively that makes us feel very much at home. Rust's native APIs, which have just become more complete over time, give us the best of both worlds. Traits and a strong type system means that we never have a problem expressing anything we've ever wanted to do. It might become verbose. Of course, it will become very verbose. But that's at the beginning, honestly, it was due to us not quite understanding how to utilize these things that Rust gives us. Now that we have we have 3 years of working with Rust in production under our belt, even the verbosity is not really an issue anymore. And lastly, but not least, the community is awesome. We love the Rust community, and the community honestly really loves Rust, to the point where when we adopted it back 4 years ago, it was kind of a joke at the time. Like if you used Rust, you were that guy, you used Rust. But now there's so much more built that being a developer in Rust not only means that you have experience with this awesome language, it also means that you've probably given back to that community in some way or another, or you've been part of a discussion where these things are happening, right? There are hardly any passive users of Rust, which is an amazing thing for a programming ecosystem to claim. How that happens is worth discussion. And in fact, the passion that users bring to Rust can also manifest itself in some negative aspects or, strong backlash over something or other. But at the end of the day, it's always with love for the programming language. That backlash is because things, might be working well. Who knows? There's a lot to talk about there, but basically the community's been wonderful and we're excited to be part of it. Like I mentioned before, robotics tools were sparse at the beginning of Tangram, Now there's a robust ecosystem. We'll get into kind of what this means for robotics in a bit and why you don't see more. But I would say it's growing and fast. So, the community gives great tools. There are great partners. Really, if you're using Rust and somebody else is using Rust, you're kind of on level ground immediately, which makes it awesome. So, originally when I put this together, I was thinking Rust for robotics. What can we do to show that off or describe that? And really, the interesting thing about Rust in robotics is that a lot of robotics is just like nitty-gritty programming. When you get it right, it's not a big bang and boom and pretty visuals. It's like, now my program ends or my program runs. So instead, what I've kind of set this presentation up to be is a lot of crates that we use in production. I'll kind of talk about how we do that, or adjacent crates that I think are really exciting coming up that we plan to adopt. And at the end of that, I want to show you exactly how we've used them and how we have not used them and have still had to rely on other languages. Because the fact of the matter is, even though robotics and Rust are very compatible, there's so much development left to do that you may not be able to work your system at the end of the day. So we'll talk about those deficits and how Rust can be used to bridge the gap temporarily, and how people are working to bridge the gap permanently through some of these exciting crates. So actually, one of the latest questions and answers touches on this a little bit, and we'll get into the interactions between Rust and C++ very soon. But for now, let's go through some production-ready crates that we use all the time. Serialization is first and foremost where I think Rust is shot. It does great. Passing data back and forth in a safe manner already nets you 90% of the gains you would need in a hardware pipeline system. Serriday, Serriday is the core kind of Rust package that helps you do serialization and deserialization across these pipelines. It's very flexible. But on top of that, you still have tried and true serialization protocols that you might be familiar with in C++, Python, other languages, Captain Proto, Flap others. We're excited for MCAP. I'm going to be honest, not necessarily because we're fully embedded into the ROS ecosystem, although that is becoming true. We're moving to ROS 2, but rather because MCAP is universal across the languages we might want to use and seems sane from a serialization perspective. There are some things we have nitpicks over, but you can DM us about those later. Just know that we are adopting MCAP. We like what it's doing. And from a Rust standpoint, it's perfectly useful right now. Visualization is something we'll get a little bit more into later, but for now, the production-ready crates that we found for visualization are mostly resigned to the terminal, believe it or not. So you have CLI table, which just makes tables in your command line. You have Rasky graph, which makes graphs in your command line. I've pasted a graph here that we actually use in our calibration pipeline. This describes the synced pairs between sensor groups. So if you're doing extrinsic calibration over time, you'll want to know exactly what time, what observations are synced between these groups. We have a little graph to do that. And this was just made in Rasky graph. We'll be porting this to other visualization tools. For instance, 3.js for our web portal. But for now, it's perfectly fine in terminal. Plotters is another one I wanted to shout out, but is not used by us. We had already created a 3.js pipeline before we knew Plotters existed. And once we saw Plotters, we were like, this is great, but the work is already done. But if you have need for a fast and interesting 2D pipeline, Plotters is your thing. Getting more into the robotics side of things, not just being able to see data, being able to interpret it. Our mathematics pipelines that we use all the time, Algebra, very heavily developed right now for geometric, computer vision or otherwise, good matrix libraries, PET graph as well. A lot of our internal structures are graph-based, And PetTraps just gives you a lot of native implementation. We'll get more into mathematics soon. This is one of my gripes with the language right now. Testing and tooling is another big thing. Prompt test, be able to fuzz your tests and get some random inputs for your outputs. This has found a lot of degenerate results that we would not have been able to find with synthetic data, for instance. Flame graphs, you might be familiar with these from other languages, able to see performance over time for your binary. Cargo license and cargo deny help us stay on the right side of the law as far as what we adopt into our software and what licenses we are able to, again, adopt. These are all, I'm going to be honest, these are all tools you can find in other languages, but given the newness of Rust, it's helpful to see that these things are production ready. We use them in production. We've been using them in production for years, and they've been able to help us through some tough times. Now, focusing on mostly computer vision crates. Image is one of the biggest ones we use. It's useful for working with image data. We actually don't use image internally as a struct, but we do transfer from image to our internal structs quite a bit. Rust CV can't be denied. It is a huge monolithic library of CV resources. If you have never seen this, I would check it out. Again, we don't use this in production, but the work that's been done by Rust CV will hopefully one day rival what's in OpenCV and be it's much more attuned to robotics and structure of motion, 3D geometry use cases. So very exciting to see that spin up. I know it's a community effort and community efforts are hard, but it's been interesting seeing that develop over time. Now, one of the things about interacting between C++ and Rust is that if you have a C++ library that you really love, bindgen's the way to go. So if you've never heard of bindgen, it produces foreign function interfaces, FFI, for C and C++ libraries. So some of your favorite open source projects might already have bindings written in Rust. You may not even know it. OpenCV is a huge example of this. So most of OpenCV's API has actually been bindgened into Rust. So this is not necessarily a port of all of OpenCV's functionality. It is wrapping the C++ and C libraries in Rust and being able to call it natively from Rust. Tangram has done this as well through RealSense Rust. So the Intel RealSense SDK had a bindgen repo, which we found lacking. So we adopted it. And now Tangram is contributing back to the community through these bindgen interactions. So one thing about adopting bindgen is that now you're getting into safe versus unsafe territory. One of the big benefits I said about Rust at the beginning of the webinar was that Rust is safe. Rust will always be safe. If you do something bad, Rust will yell at you. And this is true even when you're using bindgen. So if you work with a bindgen crate or a bindgen library that uses memory poorly, Rust will yell at you for the poor memory management in the bindgen library. So what might happen in some cases there is a lightweight API to be written on top of the bindgen crate. So if memory is being used in an unsafe way, as it was in RealSense, you just get pointers to images. And you didn't know if that pointer existed or not, and you didn't know where that pointer moved. We actually had to wrap those bindgen libraries in our own lightweight API that said, okay, this is the pointer I have, and this is where it is. This is when it's destroyed. This is when it's created. If we did that, as well as some, plus syntactic sugar on top, we were able to completely make RealSense 100% safe. So that once you got it into Rust, you knew using our API that safety was never going to be violated. This is actually what allowed us to make one of our first products, which we still use internally, which is called TVMux. So this is a snapshot of TVMux in action. you can see this video on YouTube, just search TV Mux. And basically it's me and Greg, another engineer here, juggling oranges. And we slowly plug in 4 RealSense, and you can see them start in real time. And then we unplug random RealSense, and you can see them shut down in real time without crashing the main computer, which if you used the native API for RealSense was impossible to do. So we demonstrated memory safety of the Intel RealSense library while also putting some awesome async action into this TV Mux binary through native Rust APIs. So TV Mux is really an encapsulation of everything awesome you can do with Rust in a little neat package. So when we think about expanding TV Mux, we're going to have to go through this process every time. You look at the core API or the core driver of a sensor. You say, what's unsafe? What can we make safe? We go through that. If we need a bind chain, we do. And then we port that whole thing into the TV Mux and say, as soon as this is plugged in, start the driver, make sure everything is safe, start running. And through this, we can just infinitely add sensors. They may not all stream at the same time because USB, but at that point, you understand the limitations of your hardware enough where it's not the language that's getting in your way, it's physical restraints. And so this is the perfect example of how Rust kind of transformed the way we looked at software. This would be a monumental task in any other language, but it took it took a couple of our engineers a few months to get this off and running. And since then, it's never needed touching again. Pretty amazing. So not enough can be said about BindGen. It's awesome. Working with it in Rust in a knowledgeable way means that you can make superpowered APIs that were never possible in any other language. So now here are some exciting works in progress that I think are not quite ready for prime time, but we've had them either in production, to be fair, heavily modified by us, or something we're looking to adopt in the future that's very exciting. First and foremost, visualization. I've been waiting for a Rust visualization toolkit ever since we started Tangram, and Rerun has delivered. So if you haven't heard of Rerun, go check it out. We've talked with the founders a few times about kind of the needs of Tangram, and they, even before they started on their full API, they were like immediately aligned with what we see as the deficits in computer vision today. And they just released about a month and a half ago, their visualization crate. And after playing with it for a little bit, I say it's awesome. It's exactly what we need. So go check that out. It's under heavy development. I think the Rust API is not quite where the Python API is, because of course you have to cover multiple languages, but it is natively Rust and it is natively awesome. Couldn't endorse them enough. For mathematics, again, I wanted to touch on this. We actually use a lot of these in production. So Argumin is an optimization toolbar. Now sparse is for using large sparse matrices. Fair is an up-and-coming library that does BLAS and LAPACK native operations in Rust. So all of these promise some intense speed gains for dense matrix operations and optimization operations, which is basically all we do here on the tech side. So seeing these libraries grow has been really exciting for us, and we've contributed back where we can in a couple of these. For instance, Argumin, we're still locked on a previous version of Argumin, but as soon as we jump up, there'll be some exciting new gains to syntactic sugar, structure, speed that weren't possible when we first started using it. So for all intents and purposes, these are still works in progress. But I want to be clear that as far as robotics goes, if you're doing some dense and mathematics, don't be afraid to adopt these in lieu of something where you would more appreciate something you were familiar with in C++. Now, all that being said, I got through that pretty fast because really the core of this talk is not necessarily the exciting things in Rust, it's where Rust is going. And I titled this slide Gaps in Tooling and Frustrations, but they're not necessarily frustrations that make me angry. They're just, growing pains I see in the language that is so open and so utilized and so loved as Rust. So first of all, the mathematics libraries are still nascent. I talk about argmin, naturalisparse, all these libraries with some excitement because they are exciting and they're native Rust applications for things that I thought I would never see, giant monoliths. But at the end of the day, we have still had to bygen some of our old tools that we used in past life from C++. It took us a long time and some soul searching to decide that that was the right thing to do. But at this point, it was the right thing to do. And we really haven't looked back. We're just kind of keeping our hand on the pulse of the mathematics community to see how things shape out. We've even tried to write our own sparse libraries, matrix libraries, and they have given safety, which is our main concern, but they've been slow and to the point where it really didn't make sense to keep adopting them or keep maintaining them. As we figured out by that effort, it is really a full-time job optimizing mathematics libraries. Like some of the most famous C and C++ libraries are someone's lifetime of work. You can't really duplicate that in 3 years or 5 years. And even though the efforts of the community are noble, we just adopt the tried and true for now and wait to see what shakes out. An actual frustration of mine is many of the most popular repos refuse to jump out of zerover. And the only reason this is frustrating is that with Rust, you're given cargo, which is a tool for, it's a beautiful tool for, compiling, understanding your versions, knowing exactly which software you're going to pull down. And in cargo, you can specify a crate's major version, minor version, or patch version, depending on how you want to keep up with that crate. In semver, there are understood paradigms for, this is semantic version, there are understood paradigms for exactly what a major, minor, or patch bump means. Usually major means a breaking API change. However, when you're in zerover, which means you have not yet hit version 1 of your software, every change can be different. There's really no strict protocol. If you make a patch change, it could break the API. You can make a minor change, it could break the API. We follow semver to the letter, which means when we make a breaking change internally, we just say it's a new major version. Doesn't really matter to us. We don't, we're not precious about these things. But some of the most popular crates have been utilized for years and are still on zerover. So Nalgebra, which I praise for giving an amazing effort towards a larger mathematics library, is on 0.32. When you say I want 0. whatever, your version could break whenever they decide to bump the minor version and add a lot more features. I've added a couple more popular crates, num traits and image. These have been used millions of times by hundreds, if not thousands of crates. And yet for years, they are still on zerover. What other features they plan to add to this API? I have no idea, but it kind of keeps you on your toes in a way that's not necessary. The ecosystem natively handles versioning. Handle your version. This is a very personal gripe, and I understand it might not be shared by everybody. But as somebody using Rust in production, I think it's worth knowing the side effects of having production builds break due to the crate ecosystem. Through all of this, Rust and robotics, one would think ROS, first and foremost. Where is ROS? The fact of the matter is ROS is not quite there yet. We at Tangram have been using ROS paradigms and messages for many years. But that being said, ROS 1 is out. It's being end-of-lifed. ROS 2 has not quite yet been adopted by everybody using ROS 1. And the Rust ecosystem is kind of over here while all those changes are happening to the main pipeline. So when you talk about ROS and Rust and robotics, are you talking about ROS 1? Are you talking about ROS 2? Are you talking about native APIs? Are you talking about message wrappers? There are 3 or 4 active projects around the ROS ecosystem that don't fit into any of these molds. So you can be as involved or involved with the ROS pipeline or just want a couple messages. There are libraries for you, but they're all nascent. They're all really not tied to official ROS releases or like the official ROS ecosystem. And Rust and ROS have been slow to cross each other, even though Rust and robotics is incredibly compatible. So, in a few months, Tangram is putting out some new products that rely on MCAP. We're using MCAP as the means of taking in data. MCAP is a ROS 2, or MCAP will be the native message format of ROS 2. But until people are more with the ROS 2 ecosystem, that doesn't really matter. We're still going to have to move over. And so when you get ROS, when we get a ROS 1 bag, we have this question of what do we convert it to? How do we convert it? And these questions are so myriad that we've actually created our own internal tools to handle our own specific use. This has happened very little in the Rust ecosystem. Usually we just have to tweak something or other, but we've put major engineering effort to making ROS work for us. We look forward to the day where that is not the case, but given that the ROS ecosystem is so in flux itself, I personally don't see these things meshing quite yet. It's going to be a year or two before there's something very smooth to be had there. So until then, if you use ROS and you want to pick up Rust, there are solutions. We personally are, looking into R2R for its asynchronous use. Async is really big for us. ROS 2 Rust, if you want full end-to-end kind of use for your pipeline. But if you're still on ROS 1, ROS Rust itself is something fun to look into. But I'm not making any guarantees that these things do the whole job for you. In fact, more often than not, you'll have to tweak it yourself to see the results you want. So yeah, I wish there was more to say here, because I understand that ROS is, that de facto prototyping language of the robotics community. But as somebody who's wanted to adopt the ROS paradigms in Rust for quite some time, I can't quite advocate for one thing or the other quite yet. And of course, if you want to make your voice heard, we've actually talked about this subject in the past with other groups. And once we distribute these slides, there's a link to the conversation in the ROS discourse where you can kind of leave your own feedback as to what you would like to see as these things move over. I would encourage you to do so. Very excited about these efforts. They're just not quite where you would need them in production quite yet. So I want to show you, we are a full Rust native stack, right? From top to bottom. But at the end of the day, for some things, we still use the old tools. I didn't want to paint everything as a rosy picture. And certainly the last few slides have made it clear that not quite everything's there. Our camera LiDAR pipeline, for instance, we demoed in RViz. Our visualization toolkit, sometimes it's just easier to use the OpenCV Python pipeline, right? Just register something really quick. As the up and coming crates that I mentioned become more sophisticated, you can bet that we're going to be moving to those as fast as possible. But sometimes for speed of iteration, for usefulness of tools, we just go back to what we used. At the end of the day, we always port to Rust because, again, we want those safety features. We want those mathematics insurances that we've put into our own pipeline. But, there's just sometimes you just want to go to what you know. One more thing that I think is very useful for anybody who's trying to do this in production. Tangram struggled very much early on with how to distribute our software. Cargo and Rust in a whole operate in a very open-minded way. Everything is open, everything is accessible. That's one of the strengths of the community, and I wouldn't want to change that. However, when you're trying to monetize software, having everything open goes against that, unless you're doing a Red Hat play or something along these lines, right? So actually, Tangram struggled a lot with how to distribute our software early on. This has become easier with the addition of private registries, which is not something that actually was very popular back in when we first adopted Cargo. When we first adopted it, you either distributed source or you built a binary for that machine. There wasn't anything in between. Now, or you distributed source through crates.io, to be very specific, or GitLab or GitHub or something very open. Now, with the addition of private repositories, we actually manage everything through Cloudsmith. So there are a couple of corporate solutions to this. Cloudsmith is only one of them. I think there's JFrog and maybe Artifactory is another. We went with Cloudsmith because it just had all the features we wanted. We thought we were going to be distributing source to partners, not to the world. And so Cloudsmith offered a convenient way to do that through tokens. We've now kind of backed away from that, and we're just distributing binaries, which makes a lot more sense to our partners as well. It's not necessarily because we want to keep everything close to our chest. And this allows us for much stronger versioning in our software in addition. So when we stick to semver religiously, it's really because we have a way to pull down the versions we know will work at a certain time, a certain point. So when we put out a release and we flag a release, we can just say, these are the exact versions of the software you need. Go to Cloudsmith and look those up. This is exactly how crates.io works, to be fair, but we do it in a private way instead of it public. So a little bit of a tangent, but if you're going into, if you're wanting to privatize or monetize your Rust work, this is a quick way to know that, your software will be closed. Not something mentioned a lot because, again, the Rust ecosystem is open by nature, but handy to know. So with all that being said, nothing flashy. Rust and robotics is not flashy, and I'm sorry about that. We're actually focusing on assets as a company in the next couple of months, so expect some really cool stuff. But for now, know that all the work that we've done in the last couple of years is speeding up hardware, speeding up math, speeding up asynchronous communication, so that when you plug in that sensor or you start, streaming, it just works, right? And that's really the goal of the company. It's not being flashy, it's not being cute. It's knowing that your shit works when you go. And we've tried to, hopefully spread this knowledge through our blog as well. So if you haven't seen our blog, I encourage you to go check it out. If you put in the keyword Rust, you'll see these resources, and we're always adding more. In fact, I think we published a blog post today on camera models. So if you're curious about some more math, please go check it out. And, like, subscribe, hit that like button.